Welcome back. Let us now see how to solve question number 24 in the Certified Kubernetes Administrator Killer Shell exam simulation. Question number 24, the task weight is 9%. Before we start solving the question, let's use the right context on all the terminals that we use to solve this challenge. Now, reading through the question, so there was a security incident where an intruder was able to access the whole cluster from a single hacked backend pod. To prevent this, create a network policy called np-backend in the namespace project snake. It should allow the backend pods only to connect to the DB1 pods on the port number 1111, and also connect to the DB2 pods on port number 2222, and use the app label of pods in your policy. After implementation, connection from the backend pods to Vault pods on port 3333 should, for example, no longer work. So the challenge talks about a security incident where someone has an intruder has compromised the backend pod. So we should now secure the communication from backend pod to the DB pods. And so we should create a network policy and allow the connection from backend to DB pods and only on the allowed port numbers. So before we start, let's see how the resources are organized in this namespace. So kubectl get all O wide in the project snake namespace. So we have 4 pods and 4 stateful sets. Basically, all these pods are created by the stateful sets indeed. So DB1, DB2, backend, and Vault. So backend, this is the compromised resource. So let us try and connect from backend pod to the DB1, DB2, and the Vault pods to see whether we are able to connect at this stage before implementing the network policy. Because once we have implemented or deployed the network policy, we may not be able to validate whether whatever approach we tried is working or not. So we'll take a moment to validate that. So we'll use kubectl execute it in the namespace project snake, and we'll pick the pod. So we are going to test the connectivity from backend pod, and we're going to connect to the DB1 first. So DB1, this is the IP address of DB1. So we'll try and connect to the port number 1111. So it comes back with the message database 1. So we're able to connect. Let us also try and ping this database. So we are able to ping the database 1 pod. So if ping is working, it means the ICMP protocol is enabled and working. So it uses a different port than 1111. Now let us test the same thing for the database 2 pod. Let us also give the -s switch. So this is the database pod. Let's try and connect. We have to give the port number. We should connect on port number 2222. It comes back with a response database 2, so we are able to connect. Let us also ping once again. So we are able to ping the DB2 pod from the backend pod. Let us test the same approach, but now we're going to access the Vault pod in this IP address, and they said the Vault pods on the port number 3333. So it responds back with a message, Vault secret storage. So it means from backend pod, we are able to connect to all the other pods, including DB1, DB2, and Vault pods on the given port numbers. Let us also try and ping. Yeah, ping is also working. So we're able to ping and connect to the given ports, and everything seems to be working. So once we deploy the network policy, we should kind of reuse the same commands to see whether we are able to achieve what is stated in this question. So network policy, we know this is used to restrict or govern the communication between the pods in the cluster. So it does have ingress and egress. So now we are focusing on the communication from backend to the DB1, DB2 pods. We should be focusing on the egress network policy. So let us search the Kubernetes documentation for the network policy. Search for egress. So we have this. All right, we can make use of this. Or basically, let us copy everything. It does have ingress and egress, both of them in it. Let's copy them. Let's create a file 24.yaml. Paste everything here. Let's try to modify the network policy right from the top. So metadata, the name of the network policy. The name of the network policy should be np-backend, and we should create them in the project-snake namespace. So pod selectors. So we have to use the labels for this. So let's get pods in the namespace project snake. We'll say show labels. So we have this label that says app equals backend db1, db2, and vault, using which we should be able to uniquely identify them. So we are going to apply this egress policy, matching the labels app as backend. So app is backend, and we don't need an ingress. We will delete this. And now let us write. So from backend, do we need the CIDR? There should be something with egress with names. Let's see. Let's search another one. Yeah, we can, I think we can very much use this. Yeah, we can very much use this section for doing that. So egress, let's delete everything from here on. Let's paste this. So two namespace selector. So namespace, we are focused on project snake. Pod selector, matched labels. So the communication from the pod that has the label app db1, I suppose. Yeah, db1 on, let's say TCP port 1111. So this is a condition. Let us now say one more egress rule. So so the namespace selector should match the label. So let's see if the namespace itself does have a label. Kubectl get namespace project snake dash show label. Show labels. So this should be the ones that we should use, I suppose. Yep. So this is for selecting the namespace. Pod selector. So pod, we are now setting this to app db2, and ports is a TCP port, and this time it should allow the egress from backend to the db2 port on port 2222. Let's check once again. Namespace name is np-backend. Name of the network policy is np-backend. Namespace is project-snake. Spec pod selector. app pod looks good. All looks good. So let's save this file, and now before executing, let's see if there are any other network policy in this namespace. Network policies in the project snake namespace. Nothing as of now. So let's create the network policy. It has created. Let's validate it. So it has been created. It's created 3 seconds back. Now let's do the same commands once again to test the connectivity. So kubectl get all. Let's do get pods in the namespace project snake or wide. And what we are going to do right now is we are going to use kubectl in project snake namespace exec, and we're going to so we're going to choose the backend pod, and we are going to curl the database db1 pod on port number 1111. So earlier I think it came back with the response database 1. So it's working. No changes here. Now let us do the same thing for the database 2 pod. Copy, paste on the port number 2222. Came back with the response database 2. Now let us ping and see how it reacts. So ping is basically making use of the ICMP protocol to connect to the target cluster. So it does use a different port. So since we have explicitly specified port number 2222 for database 2 pod, it's trying to reach, but it's not coming back with any response. So I think it's working. Let's stop that. So it says like 29 packets transmitted, but no, 0 packets received. So it's 100% packet loss. So seems to be working. Let's test the same thing for database 1 pod to see if the ping works. Let's give it some time and then terminate. So even here it's a 100% packet loss. So 6 packets transmitted, nothing received. So it is able to talk to the database 1 cluster on port number 1111, but not on any other ports. So that seems to be working. So so let us do the same thing, but this time let's connect to the Vault 0 pod on port 3333. So previously it was able to come back with a response something on Vault, but let's see if this is working. Doesn't seem to come back with any response at all. Let's close this. Let's also try and ping. Earlier ping was working. Now it's trying to ping. Let's give it some time and then terminate this command. Here as well, 100% packet loss. So from the network policy perspective, we have defined the egress from backend to database 1 and database 2 pods on the given ports, but we didn't give or specify anything about the connection to the vault pod. So we have secured the communication from backend pods to the database pods and the given ports, and any other communication is pretty much blocked, and we have validated the same. So with this, we conclude the question number 24. Thank you for your time and talk to you again.